Hi kids, now we'll be going with this paper discussion. You can look into the first question. The first question says, a particle is moving in a circle in clockwise sense. At all positions on the circle, the acceleration is directed towards a fixed point P. Acceleration is directed towards P. So where is the speed increasing, where is the speed decreasing? So basically this is the situation. Now at A and at B they are specifically talking about. If you draw at A velocity will be in this direction and acceleration will be in this direction. It is obtuse angle. So when you resolve acceleration, there will be one component in the direction opposite to velocity. So it will be deaccelerating. So speed will be reducing. But if you look here, velocity will be in this direction, acceleration is in this direction. Now velocity and acceleration, they are making acute angle. So acceleration's component will be along the direction of velocity. So it will be increasing the speed. So from here to here it will be increasing the speed, from here to here it will be decreasing the speed, right? The second question they are asking, when will they both have same velocity? So first guys, displacement, if you want to find velocity, you need to differentiate it. Differentiation of this one is this much, this much. Now if you want to find velocity of this guy, you need to differentiate this. Differentiation of this is this, t square is 2t. They are asking when these two will be equal. So just substitute, make this one equals to this one, right? From here you can find what is the time, right? Water droplets are coming from an open tap at a particular rate. The spacing between the droplet observed at 4th second after its fall to the next droplet is 34.3. At what rate the droplets are falling from the tap? So one drop, it has been in motion for 4 seconds. We are observing that. So what will be the distance traveled by that? Half g into 4 square. So it is in motion for 4 seconds. So half g into 4 square, when you substitute g value as 9.8, you will get it as 78.4. And the next drop is somewhere here. They said that distance is 34.3. So the gap between this drop and the earlier drop is 34.3. So let me say after first drop is dropping, after some time t, I am dropping the second one. So if this is in journey for 4 seconds, this will be in journey for 4 minus t seconds. So what will be the distance traveled by this guy? Half g into 4 minus t square. This is 78.4, this is 34.3. So the remaining will be 78.4 minus 34.3, which is 44.1. So I can equate this to 44.1. G value is 9.8. When you substitute, you will be getting t equals to 1. A projectile is projected with velocity at an angle. After t seconds, its inclination with the horizontal becomes 0. So inclination with the horizontal is going to become 0 in the sense it is the topmost point. At the topmost point, velocity will be in the horizontal direction. So with horizontal direction, it is making angle 0 degrees. So small t represents time taken to reach the maximum height. R represents the range. You need to find the value of theta. So time taken to reach the maximum height is u sin theta by g. Range is u square sin 2 theta. Sin theta is 2 sin theta cos theta by g. Now in the options there were only t square and r terms. So I am trying to calculate r by t square. R is 2 u square sin theta cos theta by g by t square. T square is u square sin square by g square. You can cancel stuff. U square will be getting cancelled. One sin will be getting cancelled. One g will be getting cancelled. It will turn out to be 2 cos theta by sin theta into this g, right? So r by t square is this much. So cot theta will be r by 2g. 2g is 20. R by 20 t square. Cot theta is r by 20 t square. Given below are two statements. Two identical balls can be thrown with same velocity at two different angles so that the range is same. So range is r u square sin 2 theta by g. So for complementary angles, range will be same, right? So if for theta, whatever is the range, 90 minus theta also range will be same. If A and B reached maximum heights h1 and h2, okay, the products of two heights in the region, okay, fine. So basically when you throw at angle theta or 90 minus theta, range is going to be same. So range is going to be 2u square sin theta cos theta by g. When you throw at 90 minus theta, this will become cos theta, this will become sin theta, range is going to remain same. So when you throw with angle theta, then maximum height is u square sin square by 2g. When you throw with 90 minus theta, sin of 90 minus theta whole square, which will be cos square. So in one case it will be this is maximum height, in the other case this is maximum height. So when I do the multiplication, I will be getting h1 h2 is u power 4 sin square cos square by 4 g square. Now if you notice here, this term is looking exactly like this term, so it's kind of square, right? So what I am doing, I am writing u power 4 sin square cos square by g square as r by 2 whole square, r by 2 whole square. From here I will be getting, when I take square root, I will be getting r equals to 4 times of root h1 h2. So h1 and h2 I will be getting this one. When I take the square root I will be getting the range. So both are true, and you can go with kind of correct explanation. Trajectory of particle is given. You need to find angle of projection and maximum height attained. So this is the trajectory. Trajectory is going to look like this, because at x equals to 0, y equals to 0, right? So at x equals to 0, y equals to 0. Now when is y equals to 0 again? At x equals to 0, and when you substitute this equals to 0, you will be getting, you can take x common, so you will be getting either x equals to 0 or x equals to alpha by beta, right? So what does it mean by x equals to alpha by beta? This thing is alpha by beta, this length. So range is alpha beta. Range is u square sin 2 theta by g, that is 2 u square sin theta cos theta by g. So range we got. Now apart from that, for a parabola, maximum will happen at this point, at the midpoint, or else if you want to find when the maximum will happen, you can differentiate it and make it equals to 0. You will be getting x equals to alpha by 2 beta. So at x equals to alpha by 2 beta, y will be maximum. You can substitute x equals to alpha by 2 beta, x equals to alpha by 2 beta, you will be getting alpha square by 4 beta. What does that mean? Maximum value of y is this much. So that is maximum height. Maximum height is u square sin square by 2g. Now you got range, you got maximum height. You can take the ratio of this one, this by this, that is alpha square by 4 beta by alpha by beta. So from there we will be getting theta equals to tan theta equals to alpha, theta equals to tan inverse alpha. So maximum height you got, angle of projection you got. From a point on the ground at a distance a from the foot of a pole, a ball is thrown at an angle 45 degrees which touches the top of the pole and strikes the ground. This is A, this is H, and this is B. Okay. Find the height of the pole. So basically they have given range. Range is a plus b. A plus b equals to u square sin 2 theta by g, but this is angle 45 degrees. So u square sin 2 theta will be 1. So this is range. Now apart from that, horizontal component is u by root 2, vertical component is u by root 2 initially. So for this point I will be writing what is the distance traveled along x axis, that is s equals to ut plus half a t square, acceleration is 0. So u by root 2 into t along x axis, that equals to a. Along y axis it is u by root 2 into t minus half g t square, s equals to ut plus half a t square. Vertical component is h, right? Now yeah, so basically what we need to find, we need to find h. We need to find h. So we need to use this equation, but we don't know t and u. So what I can do from here, u by root 2 into t, or else t I can find from here and I can substitute here. T I can find from here and I can substitute here. So this is range given. This is range given. So this is a plus b. That is range. Now for that is for range. Now for this point along x-axis I have written displacement. Along y-axis I have written displacement. Now I need to eliminate t. So I will find t from here and I will substitute. Now again I will find t from here and again I will substitute it here. U, u I will be getting, right? Instead of u I can find u from here. I can find u from here, I can substitute it back. I can find u from here, I can substitute it back, and I can get time. Once I get time I can substitute it here and here. Then it's only about calculation, right? Two particles are projected simultaneously with the same speed in the same vertical plane with angles theta and 2 theta. After what time the velocities will become parallel. So horizontal component is going to remain same. Horizontal component is going to remain same. Vertical component will be changing, v sin theta minus gt. Vertical component will be v sin 2 theta minus gt. Now if they are becoming parallel, then the direction vectors must be same, or else I can say, I can take something common, or like this coordinate by this coordinate must be same as this coordinate by this coordinate, that people must be knowing in math. So this by this equals to this by this. Thereafter it's about calculation. So yeah, I didn't solve it fully, but you can try by yourself, right? You people who are learning trigonometry, I guess. A man wishes to cross a river flowing with velocity u, jumps at an angle theta with the river flow. If the man swims with speed v, if the river width is d, then the drift travelled by him. So basically river is flowing like this, man is going like this. So if river is not flowing, then the man would have gone like this. Now because of river flow, what will happen? He will be going in this direction. Now anyway, the better option for us is resolving the vectors. U is always there, and v cos theta and v sin theta. v cos theta and v sin theta. Now if I want to check what is the time taken to reach here, that is I can take this y coordinate. Along y coordinate the distance travelled is d, so I can get the time taken as d by v sin theta. So I can use y coordinate and I can find time. Time is d by y sin theta. Now in that time, what is the distance travelled along horizontal? What is the distance travelled along horizontal? That is horizontal speed u plus v cos theta into time taken is d by v sin theta. A particle is dropped from point P at time t equals to 0. At the same time, another particle at O is thrown as shown in figure. It collides with particle P. Acceleration due to gravity is along negative y-axis. If the two particles collide after 2 seconds, find the initial velocity of the particle which was projected. Point O is not necessarily on ground. Okay, fine. So they said they are colliding. So this guy's displacement, initial velocity is 0, so his displacement will be half gt square in the direction of g. So his displacement will be half gt square. Now, if I want to calculate this guy's displacement is s equals to ut plus half at square. Those are vectors. So ut will be in the direction of u and half at square will be in the direction of acceleration. So ut plus half at square. So this is the displacement. If they are colliding, they will be colliding here, right? They will be colliding. So this guy's displacement is ut plus half at square. So if they are colliding, they must be colliding only along this line because this guy is going only along this line. So ut must be equals to this and half gt square must be equals to this. Now what is ut from the figure? From the figure ut is this distance. This distance is root of 10 square plus 2 square, right? So v naught into t. T is 2 seconds given, that equals to root of 10 square plus 2 square. Now at the same time, what other thing we need to find this angle. This angle is same as this angle. So tan theta equals to 10 by 2, which is 5. So basically we need to exactly throw along this line. We need to exactly throw along this line because their vertical motions will be same. P's vertical motion and O's vertical motion will be same. So if they are colliding, this vector is going to be same. This vector must be exactly this vector. The other way of saying it is, if he is aiming in this direction, if you look at this guy, or else if you look at this guy from here, relative acceleration is going to be 0. So if relative acceleration is 0 and if this has to collide, then it must be pointing exactly in the direction of P. Position vector is given. They are asking what is the acceleration, what is the tangential acceleration, what is the normal acceleration. Position vector is given. If you want to find velocity, differentiate this. If you want to get acceleration, differentiate this. Differentiation of constant is 0. Differentiation of t is 1. 2 into 1 is 2. So acceleration we got, magnitude is 2. Now if you want to find acceleration along velocity, so if velocity is this direction, acceleration is this direction. So you want to find what is acceleration's component along velocity, that is acceleration's component along velocity direction. So I can go with a bar dot v cap, a bar dot v cap. So I can go with the dot product of these two, or v cap is magnitude by it, vector by its magnitude, so v cap will be magnitude of v by, vector v by its magnitude. So when you take the dot product, j cap dot I cap is 0, this one is 0, so only this one will be surviving. 2 into 2t will be 4t, in the denominator will be getting 2 plus root 4t square. So that's the tangential acceleration, which is not matching with v. Now if you want to find centripetal acceleration, now centripetal and tangential will be perpendicular to each other, so total acceleration equals to root of tangential acceleration square plus centripetal acceleration square, or normal acceleration square. They are asking what is this. We know tangential acceleration, we know total acceleration. We know total acceleration, we know tangential acceleration. So we can find normal. Total acceleration is 2 square. Tangential acceleration square. So when you calculate it, you will be getting normal acceleration square. When you take the square root, you will be getting normal acceleration, right? In the figure shown, PQRS is a grass square field of side 100 meters, the center portion of mud square 50 meters. If the speed of the farmer in the grass is 1 meter per second. Okay, so basically the question is the minimum time taken from P to R by walking only in the grass, the smallest value of farmer speed in the mud so that he reaches from P to R via central mud part in the same time. So basically If he is traveling in the grass, he needs to travel either this way or this way, because the length has to be known, that is the minimum length position. So you need to calculate this length. This total length is 100 given. This is 50 given, so this will be 25, this will be 25, this is 25. Now this is 50, this is 25, so this will be 75, so you can calculate this length. Similarly, this one also will turn out to be the same length. So this total length is 50 root 10. Total length equals to speed into time, s equals to ut plus half h square, but acceleration is 0. From there you will be getting time is 50 root 10. So option B will be correct, A will be wrong. Now they are asking like this time taken and the second case time taken must be same, but they never said like how we have to go, that we can't predict. So I think they are expecting that symmetrical situation. So if he is going this way, this length is going to be how much? This is 25, this is 25, so 25 root 2, 25 root 2, this is 50, this is 50, so this is 50 root 2. So the time taken by this, in the grass it is 25 root 2, 25 root 2, which is 50 root 2. So time taken will be 50 root 2 by its speed 1. Now here we don't know the speed, we need to calculate that. So 50 root 2 by speed will be the time. But this time plus this time must be same as this time, which is 50 root 10. From there when you calculate value of V, it will turn out to be approximately 0.81. A ball is thrown vertically upwards with some velocity. Ball experiences air resistance. Choose the correct statements. See, ball is thrown vertically upwards. So initial velocity is positive. Now if you notice this one and this one, this is small and this is more. So when you throw up, it is less speed, but when it is coming down, it is more speed. That's kind of violation of energy. And apart from that, air resistance is going to eat some kinetic energy, so it will be coming down, it has to come down with less speed. So this is wrong, because according to this, thrown speed is more and thrown speed is less, but coming down speed is more. It can't happen. But in the second case, thrown speed is more, coming down speed is less. This can happen because air resistance can eat some of the kinetic energy. Now at the same time, when you throw up, acceleration due to gravity will be g downwards and velocity is in the upward direction. Now if the velocity is in the upward direction, air resistance will be in the downward direction. So while going up, deceleration is g plus a. So slope has to be more magnitude wise. Slope has to be more. Now while coming down, acceleration will be g downwards and a upwards. So g minus a. So slope has to be less. So while going up, slope has to be more. While coming down, slope has to be less. That's in this case. Here this line slope is less. This line slope is more. So this is correct. This can be correct. This not correct. Consider the given figure. A projectile from A is projected such that it strikes the ground between B and C. Somewhere, so range is somewhere between x and 2x. So range should be lying between x and 2x. Then it's only about mathematics, right? So from here we'll be getting theta. Now if for theta, if the range is between x and 2x, for pi by 2 minus theta also it will be the same. So I will try to find pi by 2 minus theta. So when I multiply with minus, these signs will be getting interchange, right? So I need to find pi by 2 minus theta. Pi by 2 minus theta will be lying between this and this. So even when I throw at this angle, let me call it as theta dash. Even if I throw at theta dash, the range is going to lie in the same thing. So either this or this can be the answer, right? A particle is projected vertically upward at t equals to 0. A constant air drag acts on particle. If Vt graph is given as below, it comes at point of projection at t equals to 3 t naught. Choose the correct options. So magnitude of slope is going to be minus v naught by t naught. So acceleration while going, this is velocity is in the upward direction. So while going up, acceleration is v naught by t naught, but in the negative direction. Now here the slope is minus v naught by this, right? Minus v naught by 4 t naught. So while going up, acceleration will be in the downward direction, which will be g plus a. While coming down, acceleration will be g minus a in the downward direction. While going up, g plus a magnitude wise, so v naught by t naught. While coming down, g minus a magnitude wise, which is v naught by 4 t naught. So they are asking the relation between g and a. So what I can do, g plus a is v t naught, right? G plus a is v t naught. So v naught by t naught. V naught by t naught is 4 times of g minus a. So I can say g plus a is 4 times of g minus a. From there I will be getting a equals to 3g by 5. B is correct and a is wrong. Now displacement. When a particle is thrown upwards, it will be like ut minus half gt square form. You know, like it will be of this parabola if there is no air resistance. If there is air resistance, then it won't be going to this maximum height, it will be going to less maximum height, and it will be going to that maximum height even quickly because someone is pulling it very quickly. Now, but while coming down it will be taking more time, but the problem is I think it won't be going more than this time, it will be somewhere here. So the time taken in this case is 2 v naught by g, 2 v naught by g, but in this case they said initial speed is v naught, final speed is v naught by 2. So in this case the time taken will be v naught plus v naught by 2 by g, that is 3 by 2 v naught by g. So 3 by 2 v naught by g has to be the time 3 by 2 v naught by g. So this has to be 3 by 2 v naught by g. This guy will be taking less time, this guy will be taking 2 v naught by g. But anyway, so without c also it has to be correct, without c it has to be more correct. Only option B is correct. That's fine. Yeah, it goes like how I calculated the time is this case. If a ball is going upwards with 20 and coming down with 16, what will be the total time taken? So the net force is mg minus kv. Mg is, I am writing in vector form mg, and this air friction, air resistance will be, oh they never said it is in the form of linear, right? Oh, they never said it is in the form of linear, it is depending on the velocity, so that's fine, that's fine. C also can be correct. So if it is exactly in the form of proportional to velocity but in the opposite direction, then you can integrate this. Now when you integrate velocity dt, it will be displacement, it will turn out to be 0. So you will be getting mg into time of flight equals to m into v bar minus u bar. V bar is in the downward direction, u bar in the upward direction. So if you want to find the magnitude, it will turn out to be v plus u. So time of flight will be v plus u by g. Now in general case, initial velocity and final velocity will be same. When air resistance is not there, then it will be u plus u 2u by g. Two projectiles are thrown at same time from different points. Projectile A thrown from point O at 3, okay, velocity is given on another projectile. So see. Now there are two things which are moving. So this guy will have acceleration, this guy will have acceleration. So when I sit on this guy, acceleration will be getting cancelled, relative acceleration is going to be 0. This guy's velocity was A and B. So with respect to this guy's velocity will be 3 extra in this direction, 3 extra in this direction. Because they said this guy's A's velocity is 3 and 3, right? So when I observe from this A, then I will be getting extra velocity in the opposite direction, Now resultant is going to be 3 minus A in this direction, 3 minus A in this direction, and if it is colliding this, then it must be the resultant of these two must be along this direction. The resultant of these two must be along this direction. So these values were given. This is origin, this is 10, 5. So this is 10 and this is 5. I can calculate this theta. Anyway, that's not needed. So if this is hitting here, so distance travel along x-axis and distance travel along y-axis must be same in it. In time t, if it is traveling this much along x-axis, it will be traveling this much along y-axis, right? So 3 minus a into t, t is 2 seconds equals to 10. 3 minus b into 5, 2 seconds equals to 5. So from there we will be getting a value, b value. They are asking mod a plus mod b, which is 2.5. A body is projected so as to pass through equal rings. This diameter is 4 given and this is 6 given. They are asking what is this angle. I think this question already came once in one of your exams. So basically I can take a projectile from here to here. Range is going to be 12. So if I take this, horizontal speed will be same, so I am calling it as ux. So if I call this as uy, the time taken from here to here is 2 uy by g. So the range is ux into 2 uy by g. Ux into 2 uy by g, that is 12. Now if I want to find this y, velocity along y axis, what I can do? I can use v square minus u square equal to 2as between these 2 points along vertical direction. When I use v square minus u square equal to 2as along this, between these 2 points along vertical, I will get this velocity. When I use v square minus u square equal to 2as between these 2 points in the vertical direction, this distance is 9, right? So I will be getting this velocity. I will be getting this velocity by using v square minus u square equal to 2as between these 2 points in the vertical direction. I will be getting this velocity by using v square minus u square equal to 2as between these 2 points. Now once I get vy, I can substitute it here and I will be getting ux. So once I get ux, I know ux, I know uy. So tan theta will be uy by ux, which is 2, right? two stones are projected along the incline, they are colliding. So if they are colliding, then their x coordinate and y coordinate must be same. So what I will be doing, this is inclined, so I will be resolving along this direction and perpendicular to this direction. This velocity is 16, this component 20 cos 37 will be 16, 20 sin 37 will be 12. So this is V naught root 3 by 2, V naught by 2. Now if they are colliding, they will be colliding somewhere like this. Now their accelerations along x axis and accelerations along y axis are same. So I can observe one from the other. When I observe one from the other, I can observe this, yeah, fine. I can observe this guy from here. When I observe from here, then I will be feeling this guy has 16 plus V root 3 by 2, and it has V by 2 in this direction. So with respect to this guy, if this guy is hitting, the meaning is this guy must be traveling along this direction. So with respect to this guy, he must be traveling only along this direction. So velocity along this direction must be 0. So with respect to this guy, velocity along this direction is 12, velocity along this direction is V by 2. So 12 must be equals to V by 2, right? So sit on one guy and observe the other guy when there are two people moving. A ball is thrown vertically upwards at some unknown velocity. The magnitude of acceleration due to air resistance is 5. The acceleration due to gravity is 10. The distance travelled in last 1 second of the upward motion. So when I plot Vt graph, initial velocity is u and it is deaccelerating at a constant rate and is becoming 0 at the topmost point. And this acceleration is 15 because deacceleration is 15. Acceleration due to gravity is 10 and due to air resistance it is 5. So if at all I conduct the same experiment without air resistance in some planet where acceleration due to gravity is 15, this line is going to look the same, but downward motion also will have same acceleration, kind of. So basically I need to calculate what is the area under this graph where last 1 second. Now this area will be same as this area. So in the new planet, where the acceleration due to gravity is 15, if I throw it upwards, this motion will be same. Now while coming downwards also its acceleration will be same. So in the new planet, distance travelled in the last 1 second of upward journey will be same as first 1 second of downward journey. So distance travelled in the first 1 second of downward journey will be half g t square. I mean g will be g 15, right? In the given figure, angle of inclination, okay. So something is thrown from here and it is hitting the thing perpendicularly. So once they say hitting perpendicularly, the better option I have is choosing this as x-axis and perpendicular to this as y-axis. Choosing this as x-axis and perpendicular to this as y-axis. So V naught cos 30, V naught sin 30. Acceleration due to gravity component sin 30 and cos 30, right? So when it is hitting here, so the meaning is velocity along x-axis is going to become 0. Now when will velocity along x-axis become 0? I know initial velocity, I know deacceleration, I can find what is the time at which velocity along x-axis is going to become 0, that is this much. Now in that time it is hitting here. Now I will be going to my original reference, I will be taking this as x-axis and this as y-axis. Now distance travel along x-axis, let me call this distance travel along, yeah, I mean this thing is y. If this is y, by taking tan 30 I will be getting this as root 3y. So distance travel along x-axis is root 3y, distance travel along y-axis is, this is y, so this will be h minus y. Distance travel along x-axis is this much, distance travel along y-axis is h minus y. Distance travel along x-axis will be given by v naught into t. Distance travel along y-axis will be given by half g into t square. Distance travel along x-axis is root 3y. Distance travel along y-axis is h minus y. So we have already calculated the time there. So you can just substitute it back, right? So thereafter you can use the equations and you will be getting the answer. Fine. Thank you.